In this week's video, pinball. Hi, I'm Adrian from Zanza's Toys, and we've been working on a 1/18 scale pinball machine lately with a couple of working play features. I released a short sort of teaser video of the two main play features of this toy a little bit ago. I'll link to that somewhere. This is still not the finished version. This is sort of like the final prototype. But what I wanted to do is sort of walk all of you through how we made it. So this is going to be the first of a multiple part video series on how we made it. So in this video, I'll be talking about how I planned out the mechanism and sort of wrapped my head around what I needed to build. And then in the next video, I'll be showing how I actually built it using FreeCAD. And in the final video, I'll go step by step through the actual assembly process of these pinball machines. So let's get into it.
Okay, so let's start planning. Just sketch out the general shape of a pinball table. We've got sort of two boxes, essentially. We've got a box in the back, and we have the main gameplay area. There's a couple other things, of course. We need some legs for it to stand up on, but that'll come later. What I want to do right now is figure out the main play features of this. So obviously this is going to be really small, so it's not going to be a fully functioning pinball table. So there's a question of what do I want to include and what do I want to exclude. There's at least a couple of things. There's, on a real pinball table, there's what makes it fun, right? What do you do with a pinball table? Well, there's a couple of things, right? There's the plunger. So we've got a plunger that you use to shoot the ball up this way, right? We've got, of course, the paddles, flippers. Sorry, so apologies in advance for anybody that's a pinball aficionado. I'm probably going to get all the terminology wrong. Just bear with me. So we've got flippers that control, that you use to control where the ball goes. Well, as best you can, right? So we've got two of those. We've got a whole bunch of stuff that goes on, fun stuff to hit, and in a modern pinball machine, this gets really complicated, and there's all sorts of it's almost like robotics going on up here, right? And we've got some sort of display here, right, that shows your score. So I'm not going to be able to do all of that, right? There's no way we're going to take a fully functioning pinball table and shrink it down to 1/18 scale without giving some stuff up. So I'm going to sort of do some compromises here. What I'm thinking is I'm going to just ignore the plunger altogether. I'm going to come back to that in a second. I think the really key thing to make this feel like a quote-unquote working pinball table is the flippers. So I really want flippers to do something. I want to be able to push a button here, have these move, and in some way interact with the ball, right? So if I'm getting rid of the plunger, how does the ball get dropped? Well, that's where I think a limitation kind of becomes an opportunity. So what I think I'm going to do is use this back box and have a hole here, basically that goes down just a little bit. You'll notice I'm drawing this offset here, more on that in a second. And basically have it be the case that you drop a small ball bearing in a hole here, and then have that come out here. So what this back piece is going to be is sort of like this. It's going to be have a couple of exit spots for the ball bearing at the bottom. So this is open here, and this whole thing fits right there. So, so cross-section wise, I want this to be a little bit offset. So what I'm doing here is I think I'm going to kind of just make this like a little mini pachinko machine inside it. So you drop a ball bearing, right? And then we'll have some stuff for the ball bearing to bounce off of. Now, I know this is going to be very small. We're talking about, this isn't too much. This is almost full size, right? Probably we want it to be about, let's see, probably something like this is about the actual size it'll be for real. But I think we can still get away with that. And what I think we kind of get for, well, not for free exactly, but that got me thinking about the number displays you get and on the backsplash of a pinball table. And I think what we can do that'll be fun is if we have a circle here with a pivot there, what we can do is we can have a little cutaway right about here, and I can design a sticker to go on this circle with numbers on it. And then the fun bit of that is this circle, if we kind of flip it on its side, we'll have a nice thin circle, maybe about 1 millimeter or so, and we'll have, you know, something, a little bit of a spacer there. I'll probably just use like an actual piece of filament, so we'll have, you know, just a about 2 millimeter hole there. But what we can do is we can put some fins here. And probably you can see where this is going, right? So if we have the back of this with fins here, right? When the ball gets dropped from, you know, a little bit offset, right? What's going to happen? It's going to hit these fins, make this spin, and that'll kind of randomize, hopefully, the position a little bit, and then it'll drop out down here. And see, this is why you want to draw stuff, because I just realized that if I drop the ball on the left here, what direction is this going to go? It's going to go this way, right? And it seems like it might be more appropriate for these numbers to move clockwise. So probably what we want is this to not be there, but we want this over here instead. And I think, so that's the plan, at least for this backsplash. So the really important thing that it's doing is it's allowing us to drop a ball bearing in and sort of letting us do without this plunger. Again, problems are often kind of opportunities, right? So as I was thinking through how that would work and thinking that I wanted something to randomize the motion a little bit, that kind of suggested this. So we'll see how that works out in practice, but I think we can make it. I think we can make it happen, and I think that'll be really fun. Okay, so now on to the real sort of like meat of this, which is the flippers, right? So what I want is I want to be able to. There's something we have to have something that we push in, right? Because pulling would be weird, right? So it's got to be something you push, and when you push it, we need that to result in these flipping up, right? So that's sort of the invariant. We need to be able to do that. Oh, and another thing that we need is we need these to come back in, right? So there needs to be some sort of return mechanism that pushes the buttons back out, right? So what I've come up with for that I think is going to work is if we take a rubber band. So let's imagine that we just had, all right, so let's say we've got our two buttons, right? And it's always good to just start with the simplest possible thing, right? So what's a good source of force, right? Well, a little rubber band has worked pretty well for me in the past. If you haven't seen my oscilloscope video, I'll link that and you can see how that worked out pretty well. So I think that's what I want to use, but what happens if we put some pegs here, right? And we loop a rubber band around them. Well, that's great, but that force is gonna act like this, right? So it's gonna keep the plungers, again, I apologize for getting the terminology wrong, which I'm sure I'm doing, but it's going to keep this would pull in, right? What I actually want is the rubber band to provide some return force. So what we can do instead is instead of connecting these directly, we can have an integrated part here that basically goes around like this. So that's a little hard to see, but it's basically like, so we have a rubber band that goes like that. So it connects to one plunger and does the same thing. Right. So this, again, is why you draw things out. So I do think this is going to work, but it's not, I have this slightly wrong. It is drawn like this, it's still pulling in, right? So what we actually need is something like this. So we'll have So we'll have some posts here. So these two posts are going to be fixed to the bottom. And the rubber band will wrap around those and pull these back out. Hopefully. That's the plan, at least. So that gets the return action, right? So I think that's getting us close. But the other thing we need to make sure that we actually actuate the flippers. So I think the way that's going to work is we'll draw kind of big. So we have a flipper like this, right? And what we'll do is we'll have on the underside of the flipper, we'll have a slot. And then, of course, the flipper will have an axle there. So what we'll do is the plunger will have a little bit that sticks up and rides in that slot. So when this pushes in, it forces this in the direction we want. Again, this is why you draw. So this would, the way it's drawn right now, if this goes that way, this is actually going to go down, right? So what we want instead is, let's just think about what this motion looks like. So we've got, that's sort of position A, right? And then we want something that's like there, right? Position B, right? And now we want to look at, if we compare, position A to position B here, what points, if any, on this shape move in this direction, more or less, right? So what we've got is, it looks like if we look at where this point is, right? On A, so this compared to the center point on A, we've got that, right? So on B, that would be about there. So it looks like we can do something with that. So if we kind of like draw that, we've got something that might work. And I think actually what we need to do is flip this relationship around. So when I first drew this incorrectly, in a way that's not going to work, as we found out, as we kind of like thought through it a little bit, right? I had this peg being a part of this plunger, and the slot belonging to the flipper. But I think what we want to do is we want to flip that around. So the flipper will have a peg, and that'll fit into the plunger. And I think we might end up needing the flipper to have something kind of like coming down, right? Yeah, I think this is what we want. This is what we want. So we'll have the flipper here, right? And then we'll have sort of a flat that comes down with a peg, and that'll ride in our plunger. So this goes that way, which will make this part also go that way, but offset from this rotational pivot, which will make our flipper go up. So that's the general idea. Let's, this is kind of like the first phase, right? When I'm designing something like this, I want to just kind of think through the general idea. I thought of most of this when I was earlier today when I was walking my dog. Obviously, you can see as I went through it, some things were wrong, right? So my idea in my head was a little bit different than reality, as it is for so much of life. But luckily, with this kind of thing, all you need to do to correct that is just take a pen and some paper and figure it out, right? So I think this is all fairly good, but now I've got a general idea. I want to at least attempt to do basically some on-paper CAD design. So what I mean by that is I like to just kind of try to draw out what some of these parts actually are going to look like. So the way I like to do that, and I'm going to not use A and B because I already have that here, but let's start naming some of these parts. And since naming can be a huge hassle, I just tend to give them letters. So I'm going to call this C, right? So this thing that exists to be a button, a tiny button on the side of the overall assembly that a user or player can push. And I'm going to call this flipper assembly, we'll call that D, right? And there's going to be a couple of parts to this main thing. So I feel like I've got enough of a handle on the back part. Got enough of a handle on this to kind of head to FreeCAD and start making it. But I think I need a little more clarity around the way the flipper mechanism works. So that's why I'm gonna give these some names, and then try to draw exactly what those shapes are gonna look like. So I need a little more paper. So let's tackle C. So this is one system, but we're gonna tackle C first. We know one end of it. Let's just, so top down, right? It's gonna be some sort of cylindrical bit, right? And on the end, very end, so over here it needs to have something that a rubber band can grip and kind of pull, right? So I think that might want, yeah, I think that the rubber band actually needs to be internal. So we want something kind of like this that goes around, right? So there'll be some peg. This will be fixed. We'll want that internal, right? And then it needs some sort of slot. Okay, so I think what we want is something kind of like this. Okay, so what we've got here is basically a cylinder, although for 3D printing, we'll probably want to make this. I might end up making this, actually, since this is going to slide back and forth a lot, it probably makes sense to accentuate that. Well, not accentuate, but I'll probably get smoother motion if both the top and the bottom are flat. So probably make this actually just a square cross section. So let's do that. We'll just say that this is a square cross section. Maybe we'll still have some roundedness here. We'll see about that. But then we're going to have a little cutout here, with the idea being that we fit the rubber band through here and put a little piece of filament. So this will be basically a peg for the filament to fit through. And then here we have a slot. So I think that'll be basically what we'll want. It's good enough to start CADing that out. Okay, so now let's talk about D. Now D being our flipper here, right? So let's talk about D. Now I already know that D is going to need to be two parts, actually, just for printability, because what I want is something that's like has the flipper here, but then right below that has this additional bit here to come down and kind of give us an offset. And the reason we need that offset is these parts are going to be tiny, tiny, right? And to get any sort of actual motion of the flipper, we need the distance from the pivot to the part that's being pushed to be we need at least a little bit of a gap there, right? Or else we're not going to get anything. So yeah, so we're going to need two parts. That's going to have, so it's going to end up looking kind of like this. So we'll have a flipper, right? Something kind of like that. And then here we'll have an additional sort of bit that comes down. And then this will have a peg. Now, this is already something that isn't exactly printable in one piece. And there's an additional problem. I guess I could print it with like this surface on the print bed and have a lot of support for this, but that's still no good, because we also need sort of in between, we need the bed, the actual play surface, right? So yeah, it's gonna come in a couple of parts, which is fine. I think what we're gonna have is the flipper itself I'm gonna flip this over, and it's gonna be a part that looks like this. So something kind of like that. And it's going to have an axle that points up. So what this will do, this part will be the pivot that it turns on, and this will also go through holes in the play surface. So the play surface is going to be it's going to be one of the easier parts about this. Is mainly just going to be flat with some holes in it for this to go through, right? And then, so we'll call this sort of like D sub 1, right, is this part. So D sub 1. Now, this part, we'll call that D sub 2, right? So that part is going to need to be something that it also is going to grip this. So it's basically going to be a part kind of, again, I'm going to draw this upside down, kind of like as it's going to be printed on the bed. And this will also be essentially this, like that. And probably we'll have maybe a little bit of raised portion here, because that is going to grip this. Yeah, so what we'll have altogether is both of these are sort of upside down from their actual configuration. So what we'll have is, this will be the play bed, or the play surface, right? And there'll be a hole there towards the side. So here's kind of like the edge of the overall assembly. And then here's our flipper with an axle that goes down here, right? So we have our D sub 1 here, right? And then here is our D sub 2 with another axle. And then that all fits into the slot on our C here. And then we have a rubber band kind of going here. So this is kind of what the front looks like. Try to get that closer. Yeah. So we've got our D sub 1, our flipper, goes through a hole, is gripped by D sub 2, which has an offset from top down. Again, it looks kind of, well, it looks like this, right? So we've got our D sub 1 is here, and then this is our D sub 2. And then this here is our C.
Okay, so at this point, I felt like I had a really good grasp on what I needed to build and how it would work. And I felt pretty confident that it was going to work out well. There was one thing that was immediately apparent about the rubber band mechanism as soon as I went to FreeCAD and started building it, but we'll talk about that in the next video. But there was one more thing I needed to do with the planning. So I knew how I wanted the mechanisms to work, but I also needed to get a feel for exactly how big things needed to be to sort of, get some dimensions. I know I want it to be 1/18 scale, but what does that actually mean? Right? So I actually have a tool that I built that helps me a lot in this kind of circumstance. So what I do is I start by getting a good reference image, and there just happens to be this really great website, dimensions.com, that has wonderful reference images for a whole bunch of stuff. So what I did is I went there and I searched for pinball, and I got there a really beautiful image of both front view and side view of a typical pinball machine. So that's great. And it's all in real world units, right? So we see that the height of the pinball machine is 192 centimeters. So that's great. That gives me a really good starting point. But of course, I work in 1/18 scale. So that's where my tool comes in. So I wrote this tool using JavaScript in the canvas that lets you drop an image in. And what you do is you draw a line on the image and you say how big that line is. So the idea being that that's your reference. So you set a reference to a set distance in centimeters, inches, whatever you want, whatever you've got handy. And then you can choose a scale. And of course, I use 1/18 scale, but there are other options. And then once you've done that, you can just draw additional lines. And what the tool will tell you is how long that distance is in your preferred scale. So the upshot of that is I can just draw lines, and it'll tell me exactly how many millimeters that should be in 1/18 scale. So I did that and got a bunch of measurements. And with that, I was ready to actually go to Freakout. This has ended up being kind of a long video. If you're still watching, thank you. I hope this was interesting. Please let me know in the comments if you'd like to see more of this kind of thing, where I kind of walk through the thought process behind the stuff we make. If you want to use the measuring tool that I made, I'll have a link in the description. Please have fun with it. It supports a bunch of different scales, not just 118. So if you're into something else, it can help you out too, hopefully. And yeah, if you enjoyed this, please consider liking and subscribing. Leave a comment. All that stuff helps a ton. And again, this is just part one of what'll probably be a 3-part series on the Pinball Machine. And I know this might have been a little dry, but I hope you enjoyed it. And thanks a lot. See you next time.